Hi everyone, exponential function, the final section about the natural exponential, and a very important one. Let's start. The natural exponential, we have seen that the simplest exponential function of the forms of a to the power of x. Graphs of the sum of these functions are shown alongside. This is where a is greater than 1. This is when it's a fraction less than 1. We can see that for all positive values of the base a, the graph is always positive because positive number to the power of x will always be positive. There are infinite number of possible choices for the base number, the a. However, where exponential data is examined in science, engineering, and finance, the base e, which is estimated as 2.7183, is commonly used, very common. E is a special number in mathematics. It is irrational, meaning it's an ending number, ending decimal number. It is irrational like pi, and just as pi is the ratio of a circle's circumference to its diameter, E also has a physical meaning. We explored this meaning in the following investigation. You may go to the investigation in the book. In the end of this, there is also a link of this presentation. There's a link to a video where you can learn more about the E, which is great. Sketch the graph of the same set of x's, the graph of y equals 2 to the power of x, e to the power of x, and 3 to the power of x, where e is 2.781. Comment on any observations. So we see the blue is 2 to the power of x, the green 3 to the power of x, and in between it's e to the power of x. So we see that this point here is common to all of them. Why is that? Because any number to the power of 0, where x equals 0, is a 1. For the general exponential function, y equals p times e to the power of qx, what is the y-intercept? So that is 0, 1. Consider y equals 2 times e to the power of x. Explain why y can never be negative, because 2 is a positive number, and we just saw that any exponential function in this form will always be positive. Find to 3 significant figures the value of e to the power of 2, e to the power of 3, e to the power of 0.7. So this is the Casio calculator. You see here shift LAN, which we'll see in the next chapter. Shift LAN is e to the power of x, where you place e, and then you place this, the number after it, 2. Write the following as powers of e. Very important part. Don't miss this. Okay, so this would be, this would be e to the power of half. This would be e to the power of minus half. This is e to the power of minus 2. And this is like e to the power of 1 times e to the power of half, which is e to the power of 3 over 2. Do it again. Good luck. Expand and simplify. We've seen some of these. So let's do that one. That would be e to the power of x squared plus 2 times e to the power of x times 1 plus 1 squared. So this would be e to the power of 2x plus 2e to the power of x plus 1. Here, this would be a plus b, a minus b, which is a squared minus b squared. And this is just developing that. Factorizing. How do we factorize? So e to the power of 2x is like e to the power of x squared plus e to the power of x. So e to the power of x is the common factor. And we're left with e to the power of x times e to the power of x plus 1. Here I see something that is squared, and minus 16, which is squared as well. But let's write it as a 4 squared. And here we have the a squared minus b squared. So e to the power of x minus 4 e to the power of x plus 4. And here we have a trinomial, e to the power of x squared minus a to the power of x plus 12. We can change that into a squared minus 8a plus 12. Solve that in with a trinomial. And then change back to e to the power of x minus 6, e to the power of x minus 2. On the same set of x's, sketch and clearly label the graphs of. So e to the power of x looks like that. E to the power of x minus 2, that's a translation, horizontal translation, 2 steps to the right. So it will look like that. And this one, e to the power of x, which is this one, plus 3 will be a vertical translation. So maybe by now you see it more clearly. The transformations on functions. Here, this is to see it really good. So this is the black one, is e to the power of x. The blue, e to the power of x minus 2, a shift to the right. And e to the power of x plus 3 is a moving to upwards. And the domain, state the domain and range. So I put that as well so you can see because we don't really remember always what's the domain and range. Domain is all the possible values for x. So they're possible negatively and positively, all x is possible. So x belongs to the real numbers, which are any number, or in other words, this is for any x. And here we see for both of them, the range is the possible y values. For these two, it's y more greater than 0. Okay, it will never be 0. This is called the horizontal asymptote, which is y equals 0. And in this one, you see the y, because it's moved 3 steps up, then it is greater than 3. So maybe by now you see how the things go spiral with all the different functions, and I hope you see it more and more and get acquainted with that. The weight of bacteria is in a culture is given by this function. You see, this looks like a growing function because E is more than 1. It's 2.78, where T is the time in hours after the culture was set to grow. So find the weight of the culture initially. This is where T equals 0. In this case, 2 times E to the power of 0 equals 2 times 1 equals 2. After 30 minutes, is this the time in hours? And this is minutes, so 30 minutes is half an hour. So T equals half. That would be T times half, T times E, and half over 2. Yeah, okay, great. So it's T times E to the power of 1/4. So use your calculator to find that. After 1.5 hours, so T equals 1.5 or 3.2. T hours, T equals 6, and so on. Sketch the graph. Once you have all the values, you can sketch them. Solve for x. Great. So now this is like exponential equations. So in this case, e to the power of x equals e to the power of half. X equals half. And e to the power of half x equals e to the power, let's put the equal where it should be, e to the power of minus 2. So half x equals minus 2, x equals minus 4. Activity, great. I love those in the book. Give it, if you can, please give it 15 minutes. You click on the icon, there you get the graph, the game. You press a new game and you see every time there's something else here, but you need to place those cards where the range and the function go together. Here the range is more than 3. You see the plus 3 is the vertical translation, and so on. It's great to you got a minute, some pressure, some time, and it goes good. makes the everything more understood. Here is the video that explains what is E. Also a great channel to follow. Thanks for listening. See you on logarithms.